So again, we're talking about modeling with sine and cosine functions. These are your real-world application problems dealing with your circular functions. And so you guys are going to be able to use real-life situations to create sine and cosine functions, answer additional questions about certain situations, and things of that nature. Okay, so guys, make sure you get down the goal, and then we'll go ahead and get started. I mean, there's not really too many like notes that go along with this because we pretty much have covered everything already when we were talking about graphing just regular sine and cosine functions, and then I'm writing equations from graphs themselves. So you pretty much have all of your notes already. Okay? So it's going to be mostly examples today. So, to create a cosine function for your data, you need to know a few things. And a lot of these are going to be data-based problems. Okay? So to create your cosine function, you need to know clearly your A, B, C, and D, your amplitude of your function, your vertical translation, your horizontal translation, and then of course your period. Okay? Because once you can figure out all of that, then you'll be able to figure out your A, your B, your C, and your D. Now, if you have to model a sine function, okay, realize that sine functions have the same amplitude, vertical shift, and period. However, the horizontal translation is 1/4 of the period to the left of the cosine curve. Okay? So if you find a cosine function to model your data, and they want you to also write a sine function, then basically your amplitude, vertical shift, and period all stay the same. You just would have to translate in 1/4 of the period. So if the period is 2 pi, 1/4 of that would be pi over 2. And that would be your horizontal translation. Okay? So we're going to take a look at some examples. All right? Now, actually, before we look at the examples, realize that in a lot of these situations, okay, you might not be given a graph, okay? You might be given data instead, okay? So to find your amplitude, it would be useful to know that to find your amplitude, it is your maximum value minus your minimum value divided by 2. That would be good to know. It'd also be good to know to find your vertical translation. That vertical shift is maximum plus the minimum value divided by 2. Okay? Our horizontal translation, usually that's probably going to be like the last thing that we find, and that's going to be based off of, our data, and there really isn't kind of like a set formula to do that. However, our period, we know, is the formula what? 2 pi over b. So these are some good things that we need to know in order to do these, okay? So now we'll look at our examples. The first one is calculator, which I think all of them are calculator. Create a model for this data that shows the depth of water measured off of a buoy in an ocean over an 18-hour period starting at midnight. Okay? So we have these respective times and we have those respective water depths. Now, before we keep going, notice something about these times. No, they're not intervals, they represent time. What do you think 0:00 represents?
12.
Midnight. Represents midnight. Then we got 2, 4, 6, 8, 10, 12, and then there's 14. What will 14 represent?
2 o'clock in the afternoon.
2 o'clock in the afternoon. 4 o'clock? 6 o'clock. So yes, this is military time. Okay? And that's what they use to represent their time. Okay? So if they did something like 21:00, what would that represent?
9 o'clock.
That will represent 9 o'clock. Okay? So do realize that. Don't be thrown off like, oh my God, what is this? Military time. Okay, so to create our model, we basically, and if it doesn't tell us what type of model to create, a sine or cosine function, well, you want to kind of look at what type of data that you have, because sometimes a sine function may be easier because you want to worry about a horizontal translation, or a cosine function might be easier. Okay, so what's our maximum value here? 9.2? Okay. What's our minimum value? 5.6. We do need to know these. Because in order to find our amplitude and our vertical translation, we need to know our max and our min. So to find our amplitude, I'm going to take my max and subtract it from my min and divide by 2. So when I subtract and divide, 1.8, can I get a second?
1.8.
Stuff. So I already know that my A is 1.8. Easy enough, right? To find my D, which represents my vertical shift, I do max plus min divided by 2.
7.4.
Yep. So far, so good. I've got a majority of my information, or not majority, half of it. Okay? Now, to find my B is going to be associated with my period. And so, to figure out your period, remember there's multiple ways we can do that. We can go from max to max. We can try to figure out how long it takes to complete one cycle. Here, we don't really have a graph, we just have our data. Is there another number in here that's kind of like a maximum or a minimum? Is you see how we have like this 9.1? It's almost up there, right along there with our max. Now, this is not going to be like an exact thing because this data, is not perfect. Okay? However, we have 4 o'clock and, I was about to say 6 o'clock. 4 o'clock, okay? So 12 hours would be from max to max. Does everybody see that? So our period would be 12. Question?
Can you just do 6.7 to 6.7?
No, you wouldn't be able to do 6. Where?
6.7 to 6.7.
Oh, that one does work out that way. Yeah, so we could have done those to those. Because that would have shown when it would have hit the same time. And we know our formula is 2 pi over b. So we set that equal to 12 and solve for b. Pi over 6. Almost done. We have our A, we have our B, we have our D. The last thing we don't have is our C. So, which one you want to create, sine or cosine? 4K.
Because last year we learned that sines more likely always the things that happen in real life, so we always did sine unless it specified due to it.
Cosines look ugly, to be honest.
Yes.
Sine starts.
Cosine looks really ugly.
Okay, and sine does start at 0. Is this one starting at 0?
No, you can find
What's our vertical shift here?
7.4.
About 7.4. And none of these hit 7.4, do they? So honestly, cosine is going to be a little easier than 2. Okay? So, to find our horizontal shift, easiest way to do is to look at your maximum point, right? Because technically, in a cosine function, the maximum occurs right there on the y-axis, doesn't it? Okay? And so we know that we do have a max at 9.2, but we also have one at 9.1 as well. Now that didn't occur right there at midnight at 0 hours, it occurred 4 hours later. So that maximum on a normal cosine function that would happen at 1200 hours now happens at 4 a.m. And so that distance from the start to where the actual maximum occurs represents our horizontal translation. Everybody catch that?
Wait, I don't understand the negative, to be honest.
Because inside it's negative, remember? Like it's opposite. We're doing something
Oh,
else.
okay. Sorry, I was thinking of it.
So it's negative because it's the opposite. We're moving to the right 4 hours. Okay? Remember, normal cosine starts at 0, 1. Okay, and that's where one of our maximums occur. But our first maximum doesn't occur until 4 o'clock in the morning. So it's 4 hours later, hence why the shift is at 4. Okay? So our equation, now that we have our A, B, and C, is y equals A, 1.8, cosine, pi over 6, x minus 4 plus d, 7.4. And that is our model for this particular data. Questions? You could also plot this data and double check to see if this does indeed model our data. Make sure we didn't mess up anywhere, okay? So let's pull out our calculators. This will be a good review for you guys, and we'll need it later, okay? If you go to Stat and you go to Edit,
Okay, never did that.
okay, it's great learning option. If you go to Stat and you go to Edit, it's the first option. Does everybody see this on their screen? Maybe not as many lists. Everyone's first list says L1, right?
Wait.
Stat is located 2 buttons from your green button,
It's below delete.
Oh.
and then you click Enter. Everybody has L1, correct? Now, if it's not empty like mine is, here's what you do, okay? You go up to L1, you press the clear button, and click Enter, and it clears everything out your list. Okay? You can do that same thing with L2. Press clear, press Enter, and it clears everything out. Okay? In L1, type in your times. Okay? We got 0, 2, and you just click Enter after every one. That's how you put it in your list. 4, 6, 8, all the way up to 18 hours. Everyone good? Go over to your L2 and you type in your water depth. Okay, so check, make sure your data's all in there, everything's good. Ready? Okay. Go to y equals. Remember, we found our equation already, and we're just trying to see if this is a good model. We didn't make any mistakes, so we're going to go ahead and type in our equation. Cosine. Don't click enter yet. Some of y'all be trigger happy. Okay. Our mode is still in radian from our problem of the day, right? Okay. Hopefully. Last thing, make sure that plot 1 is highlighted. So all you do is you go up to where it's flashing over plot 1, click enter, and make sure that it's turned on. Should look like this if it's turned on. Everyone good? Zoom 9 will show your data along with the curve that we came up with.
That's that.
Okay? So, make sure that your equation's in your y equals. Make sure plot 1 is on, and if you click zoom 9, it'll show your data and your curve. Raise your hand if anybody's calculator does not look like this. Is that the following set of data can be modeled by the function a cosine b x minus c plus d. We have our data there. It says use this data to estimate the period, amplitude, vertical, and horizontal translations. Okay, so I'm gonna give you guys like 2 minutes to figure out A. Find that information. Period, amplitude, vertical, and horizontal translations. Estimate. So the period. What was the period? 6. So that means we're going to set 2 pi over b equal to 6. 6b equals 2 pi. So b is pi over 3. Now, let me reread that again. That is not what the question asked for. However, we did need to know b for our equation. The period is 6. Vertical amplitude. Just kidding. Amplitude is 3.6. Because what's my max? I add or subtract that from my min. And what's my min? 2.2. And what was the number again? 3.6. So that is my amplitude, which is also my A. My vertical shift, max plus min, divided by 2. 5.8. And that is what variable? D, because I wanted to write my equation in a second. And lastly is my horizontal translation.
You get a 3 if you're up to the cosine graph.
Correct. So it's going to be a -3. And so that is going to be my C.
Can you just repeat what
The value to find B.
Yeah.
Okay. So we know our period is 6, yes? You think it's good?
For max.
Okay, yeah.
Yeah, okay. Question?
Would it still be -3 if the equation that they give you is x minus 2?
No, it wouldn't. It would be a positive. Thank you.
The thing is, they're asking for the translation.
Still not true, man.
You're still wrong. Translation
Is it
is
always
great, right?
gonna-
I want it for numbers.
Is the horizontal always going to be like the time to the first max?
To wherever the first max occurs. Yep.
For cosine.
For cosine. For cosine. Alright. So we have all our information to write our cosine function, which is y equals 3.6 cosine pi over 3 x minus 3 plus 5.8.
Well, if it was sine, wouldn't it be the time to the first min?
For sine, it would actually be wherever it crosses that equilibrium line of 5.8, which would be somewhere in between here and here. Somewhere between 1 and 2. Because that equilibrium line is our vertical shift, which is 5.8, and so it would be somewhere in between here and here. So, graph the function on the axes, on the same axis as the data point. So you would do that in your own time, because if it actually asks you to graph it, then you would actually have to make a graph, plot the points, and create that graph. Does everybody understand that?
Will we use the same points that they gave us?
You would use the same points you gave you, yep. So it basically you're creating your own scatter plot, and then you would kind of use, you also do it on your calculator, and then use this equation to show how it's going through those points. Okay? So I'll leave that for your homework. Part D says use the regression function on your calculator to get a sine model for the data. So for here, you would do the same process we just did. You go to Stat, you go to Edit, and you would type in your data. How do I clear my data again?
Go to the L1.
L1, clear, and enter. Go up to the L1, clear, and enter. You would type in your data, and to get a sine regression, once all your data is typed in, everyone follow me, you would click the Stat button, you would go over to Calc, and you would go down to option C. Yours will definitely look different from mine. And all you would do is you would just fill in your information and click calculate. If yours is like mine, if yours is not like mine, it would just pop up. I will put up a video so that you can see how to fill in the rest.
What is store right?
I'll put up the video so to fill in everything. But your homework is to finish off this problem and to do the last problem in